Hello, let me just double check that everything is green. It does look that way, and that means that, let's just double check. Yeah, everything is live. So, welcome everybody to this week's episode of Developers Let's Code, and we will be taking a look at NoSQL databases. I'm just quickly going to pop up a banner here so people can know what we're dealing with. Developers, I should have done my homework before. Let's code. NoSQL databases. Cool. Add, there we go. So for those not familiar with this series or set of sessions that we're doing, it's a series focused on developers that are just getting started with AWS and specifically building their first app in the cloud. So what we've been doing over the past few weeks is have an episode once a week in both the EMEA time-friendly zone as well as APJC friendly time zone. So we've been trying to make the episodes be like middle of the day for the different time zones, so a lot of people can attend. And then we cover various topics that we have heard that developers are interested in to get started in. Now, last week I covered relational databases, and we took a look at Amazon RDS. And for today, we're going to have a bit of fun with NoSQL databases. So while we are just waiting for everybody to join, give me a shout out quickly. Just tell me where you are joining from, and also just a quick indication if you've been to some of our previous sessions. I just want to get a feel for our attendees today. And also, very importantly, how is the audio today? Is this okay? Because I got a new toy for my microphone. It now has a little warm hat on. So my audio might be a bit different than it was previously. So please just confirm if someone could confirm that we are good to go. Let me just get things right on this side. That all looks good. That looks good. Alrighty then. Cool. So, like I said, we are going to be taking a look at NoSQL databases. And before we dive into, our first NoSQL database flavor, which will be Amazon Dynamo DB today, we probably have to go over the definition of what is a NoSQL database. So for that, I'm going to recommend that we head over to aws.amazon.com/NoSQL. I'll quickly pop it inside the chat for those that are interested. And this is where we talk about the different NoSQL databases that we have available on AWS, and as well as cover a couple of basic concepts around them. So let me just quickly type this in. I cannot talk and type apparently, which does not bode well for a coding session. Cool. Let's just confirm that I've got the right URL. Oh, I could have just copy and pasted it. Right. So this is how we learn. Cool. There we go. There are the links if you want to follow along today. I'll also be pasting the links to the actual workshops as I work through them today, because we're going to be touching on 2 hands-on workshops just to get started with the content they want to cover. So firstly, NoSQL. Let's start with the actual name. NoSQL doesn't stand for no SQL as in structured query language. It actually stands for not only SQL. The reason for this is that a little bit of history is that a lot of people are familiar with relational databases, like, for example, Postgres, MySQL, MariaDB, Microsoft SQL Server, etc. The reason these databases are so well known is that they're the ones that have been in use the longest, probably from like in the 90s or late 80s, or 80s actually even. And people tend to use them because that's what a lot of systems are built on. And the reason for this actually comes all the way back from the 70s, when a lot of this research was done, where they worked on certain constraints that we had with database systems. Now, back in the day, you had a computer and they were fairly new, and there were limitations, and also there were certain parts that were more expensive than others. The most expensive part at that point in time being storage. And what that means is that at that point, when they had to pick a database to use, you optimize for what is best in terms of your budget, because that was the primary constraint, because these were very expensive. And therefore, they went for relational databases because they store data in the most efficient way possible. And that's basically why so many things are built in relational databases. And then people got used to them. A lot of developers know relational databases. So you've got this kind of like snowball effect and self-reinforcing system where, because you know the relational database system, that's probably what you're going to use for your next project. So that is where it started. But NoSQL, if you look at this the title over here, it says high performance non-relational databases with flexible data models. And this is exactly it. So the flexible data model part comes in where in the way that you store your data. So like I said, with relational databases, the focus was on minimizing storage, and that's what they do. Where with the NoSQL databases, they all have different attributes, and depending on what you're optimizing for, they will have different characteristics. So let's quickly dig into what we have over here. What we can see is that NoSQL databases are purpose-built for specific data models and have flexible schemas for building modern applications. NoSQL databases are widely recognized for their ease of development, functionality, performance at scale. This page includes resources to help you better understand it, and there's a nice video in terms of picking the right database for the job as well. Now, part of what this is that when you pick your database, you pick one that's actually relevant to the job at hand. So if, let's say, you're building something like a recommendation engine or something where you want to figure out the relationship between different things. So, for example, if a person bought a sports object and they also subscribe to an interest area of fishing, what product should we give them? That's something that's very well suited towards a graph database. So using graph database will make those kind of things easy, where using a relational database, you can still do it, but it will be a lot harder. So that's kind of like one of the parts where you have to figure out what is the right database for the job that you are trying to accomplish. And then we dig into a little bit about how the different NoSQL databases work. Well, often what happens there is the way that you store your data and you shape your data allows you to retrieve your data very quickly, and also usually with just one query, not with a lot of queries. Now, what do we mean by this? With relational databases, the data is, guess what, related. So you would have, for example, if we take let's say a blogging engine, there is a table that says authors. Each author has got an author ID. Then there's a table for, let's say, blog posts. They will have a blog post ID along with the content, along with the author ID. Now, if I want to know who the author is, I need to do a select, and I say, take the list of blog posts and then join it to the authors table to be able to extract that value over there. Whereas in a NoSQL type database, you'll have everything in a single object, and you do one query. Say, listen, it might be a collection, if that's how you want to order it, by, for example, the blog post, and then the author is just another attribute on it. Or there could be multiple records, like we'll see with the music ones. We'll do with DynamoDB in a little bit. Sorry, let's switch that off. Cool. And that's one of the characteristics. So what we're going to be doing is that we'll be working through 2 hands-on labs that we are available on the AWS website for you. So you can follow along, or you can go play with it afterwards as well. The main point is being to just give you a feeling for what NoSQL databases are and when to use them. And we also have a section on that. Why should you use a NoSQL database? Well, firstly, the flexibility. They allow you to do flexible schemas because you don't have a fixed schema. So think, once again, relational database. You've got columns where most of the values are usually filled in. There might be some nullable columns, but that's the shape of the data. Changing it means altering columns, adding columns, deleting columns, those kind of manipulations. Whereas generally with NoSQL databases, it's a case of just add the data and then say persist, and it'll actually go store it, because there's no structure to actually enforce what the shape of the data looks like when you're storing it. They tend also to be a lot more scalable. The reason is that the way they are built tends to be that they can scale horizontally by adding more and more nodes horizontally, where relational databases tend to, you can only scale vertically with most of them. There are some caveats around that, but for all practical purposes, you can only scale vertically, which means you go bigger and bigger and bigger, and at some point you're going to hit that ceiling, because hardware only goes so big at some point. So that's something to take into account if you are building a highly scalable system. Also, high performance, because they're optimized for specific models and speed, you get a better performance out of them. I'm not saying that relational databases are slow. I'm just saying that these are optimized for high performance. And then also, in terms of the high functionality, the reason for this is that because they're purpose-built for the specific data models that you're dealing with. Think back to that graph database that I spoke about. Is actually easier to integrate and build with them, because if you think, for example, relational database with an object-oriented programming language, let's say Java or C#, a lot of people are used to using some kind of ORM, Hibernate on the Java side or Entity Framework on the C# side, because that's the object relational mapping bit of software that maps your objects into relational database objects. And you have that mismatch between the two types of representations of your data, whereas if you use a NoSQL database, you take your data, store it as is inside the database. So let us start digging into what we want to play with today. So what you can see over here, sorry, is a list of NoSQL databases. Let's just quickly cover that. I just want to make sure we are rounded off nicely before we get into the code. There are types like a key value, like, for example, DynamoDB that we're going to be taking a look at today. This is where you've got some kind of key that does the lookup, and it doesn't have to be a single field. You can actually do composite keys as well, as we'll see in the demo, to do a specific lookup. So let's say, once again, our blogging example, you could have author as the primary key, and then as part of that key, composite key, you can also, for example, have the let's say blog post title, and you can actually do a lookup by just the author, or the author and the title, should you want to get the information, for example. Then we've got document databases. So think, for example, MongoDB or other document database types that have that, where you set an entire JSON-like document inside a collection of some kind, and then that's how you access the different data sets. Graph databases we spoke about, in-memory ones, which is probably something we'll get to at the end of the episode, where we take a look at Redis, and then also lastly, search databases, like, for example, Elasticsearch, which is a database optimized for searching, for example, full text. So often people use Elasticsearch to centralize their log files and then be able to run complex searches across them. You can also have other text-based documents in, and then easily search for the data. So what are we going to do now? We are going to jump straight into our demo. Now, for the demo, I just quickly need to change the screen layout a little bit here. No, I don't need any of those. I need to grab, just double check here. Put that over there. No, sorry. There we go. Wrong buttons. And also, with these other two, we're going to work through introduction there. And then what I need is a console, because we are going to be playing with DynamoDB. And apologies for looking to the side. I'm making use of my second screen over here. Otherwise, I will get a little bit flustered trying to do everything here and not be able to see myself. Cool. So we're going to jump straight into DynamoDB, which is a key value database. Now, DynamoDB is a purpose-built database that Amazon built, actually, and we replaced a lot of our internal databases to actually use this. And there were some quite impressive stats from the recent Prime Day, which was from, I want to say, from 16 to 18 October. I might have the dates wrong. But basically, the point behind DynamoDB is that it gives you a NoSQL database with high performance at any scale. And when I say any scale, at peak, we received, and once again, I'll link this closer to the end, is I think 80.1 million requests a second. Yes, Remedies, you can ask any AWS questions as well. I don't want to, depending on what it is, I don't want to derail today's session too long, which is focusing on NoSQL databases, but please ask. More than happy to answer some questions for you as we go along. Cool. So what we're going to do is we're going to work through some of the tutorials. And what you can see over here is, I'll drop this in the chat again as well quickly for those that want to follow along. There's a couple of nice hands-on labs that show you how to get started with DynamoDB. You can see it in there. And what we're going to be doing is we're going to be following two of them, but we'll do them a little bit quicker than normal. The first one is just creating a table using the console so you can understand how DynamoDB operates, what the basic constructs are and things. And then what we'll do is we will take a look at how to do it with a Python application, depending on the time. So let's get started. So the first one over here is create your first table using DynamoDB console, and I've got that open over here. So what we can see is that I've already got an application up and running. So we are going to go to the DynamoDB section of the console, which we've already done because we are over here. And then what we can see is create a table. So it doesn't get much simpler than this. We go ahead and say create a table. And what we are going to do is we're going to call our table music. And we are going to define a partition key next. Now, this is where the fun starts. So the partition key is what we use to actually spread the data across the different partitions. Now, what is a partition? Well, a data partition is, if you think about, let's say, alphabet, and I partition the data between the letters that your surname starts with. So A to F is or the first letter is the partition key. Then I can say, okay, let's go create a partition, or let's say 10 partitions, and the first A to F is in partition 1, G to whatever next letter is, and you chunk them up like that into different partitions. It means that when I'm running a query, I know what the range is, and I can perform certain optimizations to get the data out more efficiently. Quick question here from Ramirez. Sign up for a free AWS tier VM instance and I install the Ubuntu server on it. I can ping out, but I can't ping in or show my web server pages. Is this firewall related? Yes. So what you want to do is you want to take a look at the security group associated with that instance. You may have connected. The fact that you're connecting to it makes me assume you've got a security group that allows SSH access in. And in there, you want to add two specific firewall rules. So the first one will be on TCP port 80, if you're running the web server on port 80. And then also for the second rule, if you want to be able to ping it, is you need to enable a rule or add a rule for ICMP to allow pings to go through. So those are two different protocols. So TCP, port 80 for the web server, and then ICMP for the actual pings to allow that to come in. And then once you've got those in place and applied, you should be able to actually access the website as well as ping the Ubuntu server that's running there. Cool. So what we're doing now is we are busy creating our table over here. And what we can see is that the next part is we have to define the primary key. Now, primary key is, like with relational databases, the main mechanism that it sorts the data on the disk, and then also how we will be able to access the data. So we're going to start off with saying we're going to call artist, which is good. And we're going to say it's a string type. And what you can see over there is that because when you think of songs and you think of an artist, they probably have multiple songs. They don't just have, well, there are some artists that literally only have one song or what are known as one-hit wonders. And in this case, the artist is useful to look up, but we probably want to do a secondary index, a secondary way to actually look up the data as well. And that's where we can actually add a sort key where we start including, for example, the song title. So let's go ahead and add a sort key. And now you can see over here is that these two combined will actually be how the data is firstly partitioned and then also actually sortable on the disk itself. So we call it song title. And now what we can see over here is if we scroll down, let's just leave that at string and string. The data types you can pick from, just quickly for those not familiar with DynamoDB, is string, binary, or number. It's very simple in terms of these fields, in terms of how it stores the data. Then we're going to go down and follow it and say we have to deal with actual table settings. Now, DynamoDB is what we call a serverless database, just for those not familiar with it. And what we mean by this is that you design the table, you optimize your queries, and you insert data into it. Everything else is taken care of for you. So you don't have to worry about doing capacity managers, setting up a server, installing DynamoDB, making sure that it's replicating, patching it, all of those things. That's all taken care of. You basically say, create me a table. You define the schema on the partitions and the sort keys on it and the global indexes, and then you decide what kind of performance you want out of the table. Now, speaking of performance, what we can see down here is that currently we are using, in terms of the table settings, the default settings, which is the no secondary indexes, and we are setting the provision capacity to 5 reads and 5 writes. Now, provision means that we say this is the baseline performance that we want to reserve for our table. Now, this means in the background, there will always be this capacity available. And there are ways that you can actually have it burst over certain times, but basically we guarantee, based on what you said, that it can actually handle that type of load. So we don't want to go ahead and untick this, because what we want to do is we want to actually change things. So the first thing we want to do is we want to create, change the capacity, because if we look down here, let's just quickly scroll down to over here, is that we want to change it from provisioned to on demand. The reason for this is that, like I said, provisioned creates capacity that's, well, provisioned for you, which means if you're not querying it, that capacity sits there, which means you decide upfront what the throughput will be, but you pay for it regardless of if you're using it or not. Whereas with the on-demand model, it's a pay-as-you-consume type model. So especially for when you're starting out with the DynamoDB table and you are using it for the first time and it's not something that's going to be busy, highly recommend that you do this, because it'll charge you a small fraction every time the query is run, and a little bit for the storage, but that's not a significant amount. For example, if you look at the second demo we'll go through, it'll be under $2 to actually run that demo for the period of time that we'll be playing with it. And now, just quickly, for those that are going to ask the question, yes, DynamoDB does have a free tier. Let me quickly bring it up. DynamoDB free tier. If I remember correctly, it's 25 gigs and 5, free tier, okay. 25 gigs and, let's go here, pricing. And I think 5 read and write capacity. units. Boom, boom, boom. Let's go to the, no, not there. I just need to double check. Actually, let's just go aws.amazon.com/free. That's the free tier. Now what we can do over here is we can search for Dynamo. Okay. What you get free per month, and this is indefinitely, is 25 gigs of storage, as well as 25 provisioned write capacity units and 25 provisioned read capacity units. And this, as you can see over here, is enough to handle about 200 million requests a month. And this is one of those, it's, as you can see up here, what it says, it's always free. So when you create your account, you can go ahead and set up a DynamoDB table with this, and you'll get that amount of capacity as well as storage for free for always. So we've actually seen a lot of companies or a lot of customers actually build on DynamoDB and never exceed this 25 gig, which means they don't have to pay for their database tier, which is actually awesome. So that is the free tier and the pricing, or the free tier at least, not the pricing. And the next step now, what we have to do over here, if we're following this guide over here, is we also want to give our or create an IAM role to use with our DynamoDB. So let's quickly scroll down here. We've sorted out our capacity. We're not going to do autoscaling because it's on demand. The second part over here is encryption at rest. Now, what you'll see is that by default, DynamoDB actually encrypts the data at rest, and it uses a key owned by DynamoDB. Now, you can change to other keys. So, for example, you can use KMS to bring in your own key that you manage yourself via KMS, which is the key management service. Or you can go to KMS and actually generate a key that's managed by AWS. So if we did that, for example, you can see there's always a service level default key available. But if I had another key that I created, I could actually use that to encrypt the data at rest should I want to. But by default, it uses an internal key that you don't have to worry about. Cool. So what we want to do next is that under the autoscaling, why am I not seeing IAM role? Let me just double check. It's under provisions. Provision capacity, autoscaling. Here we go. So this is the interesting part. If I want to autoscale, I need to be able to change the actual table configuration. So in other words, change the number of read and write units. And to be able to do that, I need to, let me just quickly make that a little bit smaller. Let's do this. Does this? Yeah, this works. Which means that I need to actually modify the table. And we do that via some code in the background that makes use of this IAM role, which has permission to actually do that. But like I said before, in our case, we don't want to worry about all of this autoscaling and target utilization and all of this complexity for now. We're going to keep it very simple and just say on demand, and it uses that. So we're going to go ahead and create our table. And that's going to take a second or two. So while we're waiting for this to complete quickly, thanks for joining. I see a couple of new people have joined. Today we are taking a look at NoSQL databases from the perspective of someone starting out on AWS. And specifically, we're taking a look at the Amazon DynamoDB as a key value database. And we will then also take a look at Redis as part of Amazon Elastic Cache, how you can spin up a single instance, or if you want a cluster node spread across multiple availability zones to have high availability. We'll take a look at that as well. So let's take a look over here. Our table is now ready. Sorry, it's a little bit squished, obviously, with the dual screen. I would still want to make it readable, but please let me know if you can't read or if you want me to highlight a certain section some more and spend some more time on it. Cool. Okay, so now we need to start adding some data to our table. And what we have over here is, if I take a look, is this is my table. Actually, let me just quickly bring it up so you can see the full screen. So this is what it normally looks like if it's not squished to the side like I just did. And we can see there's a whole bunch of values over here in terms of that we can configure the database, get some insights, set up backups, global tables, which allows you to replicate the data between different regions as well, etc. And you can see all the table details down here in terms of creation date, encryption, all of those. So what we want to do now is, and let me just quickly get it to the side, there we go, again, is that we want to add some items. So we're going to go to add items. And over here, we can see that there's no data inside our database, which is not surprising given that we just created the database. So we're going to go create an item. And what you'll see is that it asks us to fill this. And what you can see is this will look like, it'll actually look like JSON, because ultimately at the end of the day, the way you interact with it is to build up a JSON payload and then deliver it. against the DynamoDB API. And we need to provide the artist name as well as the song title. So let's just follow the tutorial so we don't make any mistakes. So the artist is no one you know. Let's do it that way. Up. And I'm going to copy that because we'll use that a few times. And the song is Call Me Today. Cool. Save. Now what you can see is we've got our value over here. So now we've got some data in the table. Now what we can see is that we're just going to scroll past and we're going to actually add some additional entries over here. So I'm quickly going to do them. Same is that. The song title is my blog spots. Add, save, create item. Same as somewhere down the road. Save, create item. And now we put a different band, which is the Acme band. Let's paste that back in again. Still no love. Still in love. It's getting a little bit depressing here. Still no love. Save, create an item, same band, and look out. Well, there we go. Is that a double space? No, single space. Cool. Okay. So we now have got our data in here. Now what we can see over here is that we want to be able to query the data, the table. And now what we do is we can, if I just make this a little bit bigger to actually take a look up here, is that I can actually query. So let's do a query instead of a scan. So what a scan does is literally, a table scan is normally something that you don't want to avoid because it takes the entire database and loads it. And that's normally a very heavy operation because imagine you've got millions and millions of rows. You don't want to load the entire table. Similarly, when you do query data on the table, you don't want to perform a table scan because that ultimately requires you to look at every single entry inside the table, and that tends to be very, very slow. So if you ever see like for example, if you go to the relational database size, a table scan, definitely figure out how you can add an index or optimize the query somehow to make it go a little bit faster. Cool. So now what we're going to do is we're going to do a query. And what we can see over here is that I can, for example, search with the partition key as well as the sort key. But if I say, for example, the partition key, let's enter a value over here. Let's say no one. But it's equal. So no one, you know, needs to be in there. And then in terms of the sort key that we have over here, we can say between begins with all of these. So let's go look for anything that starts with an S quickly, and we can do a search. We do a search, and you can see that's a very quick query. Now, obviously, this table isn't very full at the moment, but this is one of the benefits of using a NoSQL database. And also, remember, DynamoDB is also built specifically to operate at high scale. Is that if you use your partition key and sort key correctly to, well, be able to index your data, it means that you can access your data really, really quickly. Just quickly, as we go along, please ask questions if there's anything that you are interested in or if it doesn't make sense. More than happy to dig into a little bit of the questions as we go along. Okay, so that, let me just quickly get this back, is how you would do, for example, search. And what we could do is, let's just take a look quickly what happens if it's going to get a little bit, there you go. So, ooh, what do I do now? Here we go. Sorry. If we, for example, didn't have anything in here, we just leave it as equal, and then we say go ahead and search. Then we get all the entries. So you see the flexibility that you get here with the way that you set up the partition key along with the actual sort key. Cool. We've got our first question by GeoDMB. Let me quickly pop it on the screen for you. Boom. Also, welcome. I know you normally come to a lot of our other streams. Does this have some sort of auto optimizations running in the background? With MySQL, you would have gone and optimized repaired tables now and again. I'm assuming you refer to the fact that we are doing this table, being able to do this lookup quickly, or are you referring to the fact that it's super high performance in terms of how it stores the data? If it is the latter, it's just the way the database engine is built where it actually stores the data. Now, normally, the optimizations and repairing of tables that GeoDB refers to is with a relational database. You can think of, you've got your table of data with individual rows, and that's how, depending on the natural sort order of the table, how the data is represented on disk. And that normally, if you create an index, if you create a primary key, and it's by default, if you don't specify anything other than the primary key, that's also normally the sort it's got a sort value on it in terms of how to sort, and that is what is used to represent the data on disk, which means that when I've got this block of data and I need to insert, for example, something here in the middle, I need to first make a space for it by moving the other data down, then insert that record over there. Now, the insert is easy because you obviously just keep growing the table. What happens, however, over time is, let's see if now I've got a big table like this, and now I start deleting records here, here, and here. That leaves gaps in that table. So over time, you don't want to, because moving data is expensive. Now, when you're inserting data, obviously you have to do it because you don't want to lose the data. But when you then delete data, there sometimes are gaps left, which slows down the process. So you want to go and compact the tables again and clean them up and optimize them for that. Follow up on the question, which is, for example, in WordPress database in MySQL 5xx, optimizing repairing tables would improve performance or fix issues. Now, given that it's in the context of WordPress, there are ways, for example, like rebuilding an index, because at the end of the day, everything is a trade-off. And what it boils down to is that, let's say I've got an index on a database, on a table, and this is now with relational database again. And if I do an insert, what happens is, firstly, I take that data, I have to write it to disk, and then I have to put it inside the right specific spot based on the natural sort order of the table as it's represented on disk. That's step one. Step two is I actually have to go update the index, because now I want to insert that, however I define my index, into the actual index, which is data separate from the table. Because that's what allows you to go, if I do a lookup, because I know the order of the index, I say I need something between the 1st of December and the 3rd of December, and that's an index column. I can immediately go look at the index column and say, boom, this is the section that I need. I get that information. Then from that, I can go actually extract the data from the actual table itself. So what sometimes happens there is that you have to rebuild the index if it's not optimal. But more likely what happens over here is that as time goes along, it actually builds up statistics about how data is accessed and which index performs better than other indexes. And using that information, it does a query plan. Now, when you do optimizations, what it'll do is it'll recalculate some of those statistics and actually build up possibly a different query plan for you. And that's how the optimizations kick in and actually become more efficient. We've got some more questions. Quick, when we create a partition and sort key for the next set data has to adhere to the sort and partition. If my existing set of items that are not using the same sort and partition, do I split that into a separate item? Just need to compare with a relational database. Okay, cool. So we do get this question fairly often in terms of like the data, how you store it on disk looks a lot different with no relational, NoSQL databases than it does with relational. Because with relational, we put the data on the disk. We've got a primary key, which is, like I said, normally the sort key. Then we've got one or more indexes. So there are different ways we can actually look at it. Now, if we think about the data that we are dealing with in this specific example, we have got what appears to be a single index that we can work with, which is the partition key as well as the sort key. Now, the good news there is that you can set up a secondary, global secondary index as well to actually look that up. So you always have to think about what are the ways that you will be accessing your data and what to include in your actual secondary indexes. So, for example, I can say that the secondary index is on the artist and the album, but also includes the actual song title. So when I do a search and say artist and album, it gets that, but part of the when that retrieves also has the song title in it. So it doesn't actually have to get the data from the index, use the index to go look at the data on disk as well. So that's one of the ways that it actually helps improve performance. Cool. Let me quickly have a look here. Next question. So if I understand this question correctly around Cognito, is this if this is where you want to store additional data about the user in terms of I don't know, values that you don't have in Cognito at the moment. If you can clarify quickly, then I'll see if I can answer the question for you. But I think if that's what you mean, yes, you can easily use the DynamoDB table, use the Cognito identifier as a mechanism to look up additional data about the user, if that's something that you want to store for your system and actually use. Cool. Let's have a look over here. What kind of filter expressions can you use with scan? Does it work like SQL? Yes and no. Yes, in the sense that you've got control over what you want to use to actually search for. So if we look over here, for example, we can see that, well, scan by default, when you just go to scan, you'll see that you can add a filter and say, listen, look for a specific attribute name. Now, in our case, let's say we say the attribute name is artist. or just if I can spell it, and we say the string is equal to no one you know, and we say start search. We can see over here that we get the same results. So actually, let's just change it to the Acme, what is it, the Acme band, I think. Start search. Yeah, there we go. So you can get the same data out, but remember, a table scans the entire table. So what it does, it says, go through every record, use whatever filter I've got to find, and does this row match it? If it does, bring it out and put it in the result set type scenario. So in that sense that, yes, you're looking at it on a row-by-row basis and you are trying to search with it like you would with SQL. The difference being is that there's no way, as you can see over here, to do a join between data over here and data in another table. That you would have to do in an application layer, but typically we'd advise against that and say, listen, rather think about how rather to design the different attributes inside your DynamoDB table to have subsections for different fields inside it to be able to store that data instead of trying to join everything. Because remember, with NoSQL, we're not optimizing for disk space, which means data duplication is perfectly fine. So if you think about your data on disk, if I have band name along with album title, along with actual song, the fact that there are 50 songs, for example, well, let's make it 10 songs from an album, and you've got the album name 10 times and the artist name 10 times. The fact that there are 10 copies of that specific two data sets or data points doesn't matter because disk space is cheap. We're not trying to optimize for that. Let me know if those help. Also, Jobar Joe 1010, just let me know if that cognito question helped you with what you were doing. Oh, wait, here we go. Follow-up question. If we store additional user data in DynamoDB, does it make sense to store all of the user data on DynamoDB and avoid cognito API calls to retrieve data such as email or phone number? Unfortunately, the answer here is it depends. The reason that I say it depends is that, remember, Cognito and DynamoDB are two different systems that they're solving different needs. Cognito is a system that allows you to manage users and user pools, takes the care of things like, for example, resetting of passwords, sending a verification mail to confirm you've got it. And I have a guest. I will continue with the question just now. I just want to join in my twin. And hello there, Darko.
Hello. Hi. I'm good. I'm good. Thank you. Hi.
Introduce you.
Hello, everybody. My name is Darko. Darko Mesaros. I am a developer advocate, the same as this gentleman up above me. Basically, everything that he said, I'm the same thing, except I live in Germany. So.
Oh, so you're a DynamoDB expert. Nice. You can help us then.
I'm sorry, I have to leave. Hello, everybody. I'm just here to keep Koba's company and attempt to answer questions.
Quick one, Darko. I didn't get a response from the audience. Is my mic okay?
Yeah,
Can you hear me cool?
It is. I was listening to you actually. Ooh, you have the fuzzy thing.
Yes, the fuzzy thing.
Yeah, that's very cool. Yeah,
it's like a little rodent. Okay, cool. So I was just answering this question currently. We're busy working through a hands-on lab for DynamoDB, and the question that we have is that if we store additional data from that we'll restore about the user, can we store it in DynamoDB? And the initial answer was yes. And then the follow-up question is this one, which is storing additional data in DynamoDB, doesn't it make sense to store all the data in DynamoDB? And the answer is, well, kind of depends, but basically no. The reason is Cognito, the basic details like first name, last name, email address, telephone number, I believe, if you use that as a sign-up mechanism, all of that is built into Cognito, and that should be the source of truth, because also that helps you with password resets and managing users and all that. It's literally built to handle that. So while you can have that info in DynamoDB, you'll be duplicating it.
Yeah,
cool. Yeah. Alrighty, quickly just going through over here. Yes, Darko and I really like streaming together, and it's much easier for me because just sitting here blabbing for an hour on my own is very hard. I struggle with it. Now at least Darko can laugh at my jokes, or not laugh, or just cringe.
I can absorb your jokes.
Yes. Awesome. But yeah, keep the questions coming as we go along. And also quickly, no, unfortunately not.
We're trying to make that as a requirement, but somehow it doesn't go through HR. I'm not sure why. Yeah,
cool. Okay, before we derail this completely, we were busy looking at how to do queries versus scans on the table, and we just covered what the difference with a scan and a filter is. So for example, now let's just quickly add another filter over here. Now what you can see over here is that the filter is immediately an AND, because remember, with NoSQL, it's not like we can do with normal SQL statements where you can grab different rows based on different things. This is always refine based on all of this. So let's quickly say the attribute over here is, say, song title, and we say begins with, and we say over here L. I can see the L. Now what we should see is when I do the search over here is I'll only find the one entry, and this is how it works. And you can keep adding filters to keep narrowing down, but at the end of the day, it's with ands, not with ors. Cool. Alrighty, so quickly moving back to where we were over here in our little hands-on lab. It's actually covered the searches and how to do a query versus a table scan. What do you think of DynamoDB so far?
I mean, I'm not a big data expert, so I've in my life I've only used like relational databases, right? MySQL and Postgre. Never used actually NoSQL in an actual production setting, but seeing that NoSQL databases such as DynamoDB can cover most of the things you want to do. Well, can cover most of the things you want to do. I find this is a very easy way to get started. The only weird thing about NoSQL, or actually DynamoDB for me, was the query thing. Because, you know, when you interact with databases, you expect I'm going to use a database-specific language for this, or a SQL, right? Server query language. You're going to connect to the database, get your run your query, get the data back, and then do the stuff with the data. In DynamoDB, you use an API call for that, right? So you have an additional layer of abstraction on top of that, and you use to basically access the data through a scan or something like that. So I think that's, it took me a while to get used to that, but especially coming from a traditional background. So.
No, definitely. I mean, this comment by Denny 1111 here is that it's kind of hard to get if you don't know what your full access patterns are. I do want to point at, is that book by Alex Debris free?
Alex
I can't
Debris.
remember. Alex
Yeah.
Debris, DynamoDB. Let me
book.
quickly bring it.
It's called the DynamoDB book.
Here we go.
Yeah.
Yes. Okay. There we go.
It's amazing. It's apparently, haven't read it, but apparently, according to the folks, it's worth every penny. So.
Yeah. So what I'll do is I'll pop that in here. This is not an affiliate link. I unfortunately, well, even if I this did give money, I wouldn't be allowed to accept it. But this is, like Darko and I said, a lot of people have said this is a really, really good book to help you get started with it. And make you understand the concepts, because it is different from relational databases, and it does take quite a bit of time to actually figure out the differences and understand them. But we were busy. There was another question over here that I almost missed. I'll get back to it. Cool. Here we go. NoSQL doesn't store data on disks. Then where does it? So yes and no. It depends on what you're dealing with in terms of what flavor of NoSQL. So if we're talking DynamoDB, that definitely stores it on disk. If we're talking DocumentDB, that definitely stores it on disk. If we go to something like Elastic Cache with either Memcache or Redis, that, however, doesn't by default store it on disk. It keeps the value in memory. It's an in-memory database, and the reason behind that is something like Redis or Memcache you use, for example, retrieving session data. So let's say you've got 50 web servers and you store your session information about if someone's logged in or not. You put that in Redis. When you do that lookup, because you're doing it directly in memory, it is incredibly quick, and that's the purpose of that database, is doing those kind of lookups very, very quickly. It does have a mechanism to persist the data, but that's not the main focus of the database. So it depends on which ones you are dealing with in terms of whether or not it actually stores. Rudy Quills, quickly, what kind of disk is used for DynamoDB? Under the hood, that tends to be a very interesting question. It'll likely be some form of SSD stored somewhere. I mean, we still have got the old, as they're called,
spinning disks.
What's it called? Spinning Rust.
Yeah, spinning Rust. Yeah. But actually, I think in 2020, on scale, it's cheaper to store data on SSDs than magnetic disks. So even sometimes, we might just be using SSDs in the background, and you don't even know it. So I think the important, especially when it comes to the cloud, is you should not care too much about what kind of disk it's spinning on, as long as it's getting you the right IOPS. So that's it, or the provision requirement, or read-write capacities and those things. Yeah.
Yeah, and also just to clarify over here, there's a comment around maybe NVMEs. Those are the little, they look like little chips, disk drives.
Yeah.
I don't think we use those as the bulk. There are definitely instances that have them, and we use them in specialized systems, but I don't think they make up the bulk of our storage just because of the cost at this point in time. It gives you super high performance, but yeah.
Exactly.
Cool. Okay. Let me just quickly double check. Let's hide this one over here. Cool. We are good with questions for now, but please keep the questions coming. It's always more fun if we can actually explain things to our viewers instead of just, like I said, randomly blasting into the ether and hoping we entertain and educate at the same time. Cool. So now, next part. Because this is a getting started session and we're doing some very basic things, now we can also show you how to quickly delete something. And that is not very hard. What you can do over here is that I can select this, and over here I've got an action. We can see now I can decide what to do. So I can just delete it directly, or we can quickly play with the TTL. Now, for those curious about TTL, that stands for time to live. And this is a super useful feature in DynamoDB, is that when I insert a record, I can set a TTL on that record and say, after a certain amount of time, this record should be deleted. So let's quickly do that. So TTL attribute. Now, obviously, it'll take a while to actually apply this, and you can actually preview it. So because it's going to take an hour, it's actually not going to be feasible to do that. So sorry for getting your hopes up, but this becomes useful because, like I said, you can automatically eject or delete the value out of the table. But it's canceled that. Sorry, I was hoping I could do that easily and quickly now.
But that's a very good use case for some transient data, because this increases the flexibility of NoSQL or actually DynamoDB to use it for some transient data that you don't need don't need it at all. And today on the stream, Javier and I were discussing about junk data. There is such a thing called junk data because some things you just don't need at all. Like no matter what you're have it with, and once it expires, you just can throw it away. And this is a great way to do it.
Yeah, no, definitely. I mean, it's like always when you think about storing data, try and store as little as possible in terms of what you need for your users. Because with all the new privacy laws and things in place nowadays, you don't want to just store every single data point unless you have a need for it. Now,
correct.
You have to balance that with you might need data for future features, things, but that you have to think. Denny has brought up a point that says one problem I have with DynamoDB is data corruption in case of developer mistake. Yes, that is a very valid point. But what you can do is backups. Yeah. And what we want to do is, firstly, we want to enable point-in-time recovery. And this is a very, very useful feature. So let's go ahead and enable this. And what you can see over here is that you can select restore to restore at a specific point in time, and it'll restore it to a new table. So you can actually just go change your code to point to this new table. And you can say, listen, restore from a specific point, and you can do the entire database or without secondary with a whole bunch of configs over here. But this allows you to pick a very, very specific point in time and actually restore to it, which is one way to get around this issue of developers making mistakes. But also, please create a backup. Set up some kind of schedule for your backup. Backups are good. Backups make you feel warm and fuzzy inside. And also when the day comes along when something is broken. And then the second part of backups is please test them, make sure that they're working, make sure that you know how they work. Because the last thing you want to do is, under pressure, realize that everything is broken and the database or the backup is either empty or doesn't work, or you don't know how to apply it. That does also happen sometimes. Ooh, sorry, wait. Oh, sorry.
What happened here? You broke your screen.
No, it's fine. It's just Windows is hard because I do some weird key mappings with Synergy and my MacBook to swap keys around. Well, double swap keys around effectively. Yeah. Cool. Here we go. Which are the reserved keywords for DynamoDB? I tried sorting key type and it does not allow me to query. Yes.
I just posted I posted the link. So.
Okay, cool. Okay, awesome. Thanks for that, Darko.
There's a
this
whole
is why you want to have a friend.
There you go. There's a whole list of keywords that you cannot use because they're kind of specified to DynamoDB. So type, for example, less, key, integer, having, heap, hash. So it's a massive list. So make sure to use these things. Yeah.
Yeah, but I mean, you'll get an error when you're trying to use them.
Exactly.
Don't worry. Yeah. Let's click on this. Performance that creates a new table. Yes, so it does create a new table. The reason is you don't want to restore over the old data because then you lose all of that old data in the corrupted state. So it's better to say, listen, let's quickly shut down the app, change the config, point to the new table that has got the correct data, and then figure out how to go from there. And then you can always go delete that old table again. Remember, we're just dealing on a per table basis over here. So there's a benefit and there's a reason for this, because the trade-off is restoring over that old one. And now you've done that once, and now it's, oh crap, now I lose my data. Because remember, the way the data is stored underneath and allowing you to do this point-in-time recovery is part of some interesting storage mechanics there with figuring out the difference between each transaction change on the table. But yes, Denny, very good rule, and this should go up here, and this should actually be a little poster and a sticker, is you have to be careful in prod. Exactly. I would also want to ask at this point is, if they are breaking data in prod, why do they have full access to the database and they are interacting directly with the database? That's normally a warning sign and an anti-pattern. Yeah. You don't want people to, especially on a production database, just run queries directly. Ask me how I know. Day 2 almost got fired. Locked out everyone from our production database. Wow. Not Amazon, elsewhere, yes. Wow. It was a very, very interesting experience. But bottom line is I should not have had database access. And also, I would not give myself database access. Imagine someone pitching up second day at work. They want to do SQL, and you ask them, listen, so tell me about the SQL experience. And they tell you, well, it was great using pen and paper to do this. Actually, pencil and paper, so you could erase things. Yeah. I had never run a query by hand, so yeah.
I think if you want to do something with production data, there should always be a replica of the production database that you can use to play with. And that's like production databases, unless it's something really serious, and that has to be something major that you need. You should never run any SQL queries outside of your application to a production database, right? Like no PHP MySQL, no SQL Workbench for a production database. No, doesn't matter, right? So
yeah, it's one of those, like, really, you don't touch them directly. You do it via applications and things and deal with it that way. It's like, it's just a recipe for disaster.
Correct.
Quick segue, because I do I'm keeping an eye on the time, and I see that we are 10:02, and I know we can run over a little bit if we want to till past, I believe.
Okay.
So the second hands-on demo that I want to do is I want to show how to use Python to actually programmatically create a table and then also access all of that. But if we go to this list of tutorials that I shared earlier, you can see that it's the second one over here. And what we can see is that it's got actual steps, and we can follow these steps one by one and actually go through them and show you how to set up all of those things. Okay. But I think what would be a little bit more valuable right now, instead of doing that, is let me quickly show you how to create a cluster or a Redis cluster. Just as a quick, not console, with capital CON. Because I want to show you. So Elastic Cache over here. So Redis falls on Elastic Cache, and you can figure out whether you want to do Memcache or Redis when you create them. So let's go ahead and say, let's create a cluster now.
Okay.
And here you can pick between Memcache and Redis, and you'll see that Redis is the only one that has got cluster mode available. So when you think of cache, you might be able to get away with not having to cluster your cache or have it span multiple availability zones. In production, this could be a bad idea, because remember, you're specifically using these in-memory database caches to, guess what, speed up your system. What do you think is going to happen when that cache disappears?
It's going to slow the system because,
yeah.
By the way, I've a kind of a small digression on this. I had a customer who ran a production database on Redis, like Redis or Memcached, like persistent data. The database.
Well, Redis does have an option to write to this, and you can set it up to replicate. Some performance characteristic changes because of that, but you can. But it still is that would also scare me.
The problem was that I think they were using Memcached because after reboot they lost all their data because.
Oh yeah, that happens. Guess what? If you yeah.
But it was so fast. The database was so fast.
Yeah. So quickly, feedback here from Rudik's World, just popping on the screen. A quick feedback about DynamoDB. I found last evaluated key and consumed capacity very useful. What is missing in my use case is something I'll call affected rows. Somehow many documents in total are in the current query. I hear you. That would be useful, but you could also just quickly do a count on the collection returned. So you should have collection.length available, I think, for that. At least that's how I approach it. But it's worthwhile. I'll definitely pass this feedback on. Cool. Okay, we want to spin up a cluster. So there was another question over here, which is, use Elastic Cache. Does it use EC2 in your account? Yes and no. Under the hood, when we have things running on compute, it runs on EC2. It might just not be an EC2 instance that you see in your EC2 portion of the console. But it uses the same virtual machine setup. It's just pre-configured, and we as AWS manage it for you. So in this case, yes, it uses EC2-like virtual machines under the hood, but you don't have access to that machine at all.
Correct. It's a managed service, so basically it is running on EC2, but you don't have to worry about that. Think of it as an endpoint and just use it as such. So
yeah. So what we do is we're going to say cluster mode enabled. Sounds like a modification, and then what you can see over here is that you can run it in your account using AWS, or you can actually run it on AWS Outpost nowadays. If you've got Outpost, that is a physical rack of servers that AWS wheels into your data center, and then we manage it and it actually connects to your account, and it shows up in here. But we're not going to cover Outpost today at all. Cool. Okay. Now let's give our cluster a quick name. Let's make it personal. It keeps things in memory. And you can pick the version number here. I'm just going to stick with whatever the latest version is. Standard port. Parameter group is we set additional configs. And the node type over here, this is where we pick the size of the instance. And you can see that it defaults to the R family, which is the memory intensive ones, because an in-memory database tends to need memory. So, but you can pick. So over here, you can see it defaults to the Graviton version. So it's actually ARM architecture running. But you can also use something, let's say the T family of instances, if you want to have less memory and also not pay as much for the cache, or you've got smaller needs, entirely up to you. So we're going to go with, let's say, T3 micros, save that over there. And then over here, what we can see is that the number of shards, which is when you've got your entire data set, how many shards you have. So a shard goes to one server at a time. So I split my data in 3, and there's a shard key. So let's say surnames again, and I use A to A to F, G to N, and then O to Z, or Z, as the US people say. That's the shard key that determines where the data goes. Now, please don't use that shard key because it's terrible. Surnames are not distributed uniformly across the alphabet. But that's basically how it shards the data across those different ones. And then what I say is that I want at least 2 replicas per shard, which means that if I have over here, what we can see is that, because remember, that shard is the only copy of the data in memory. So I now want to have a second copy on one of the other nodes and actually store that. You can see over here that you can input between 0 and 5, because that's the way it's set up. You can have up to 5 copies of the data. Now we want it multi-AZ because we are concerned about, if we lose our cache, life becomes very, very unhappy. And we've got a subnet over here that I've already pre-configured, but I could go ahead and create a new one and just call it here we go.
Darko subnet. Thank you.
Yes.
Thank you, Covid. I love having infrastructure pieces called by my name. So.
Yes. We're all playing words on the darknet over there. Cool.
Yeah.
And over here, what we can see is that multi-availability zones at least 2 or more subnets. The reason for this is a subnet is specific to an availability zone, which means we want at least 2 of them. So let's go ahead and select 2 of them. There we go. You can see when I adjust one, it's complaining, which it should, because guess what? That's not high availability. Okay, then over here, we've got slots of key spaces, how we want to distribute it. We can do custom distribution if we want to, and this is where that sharding comes in and how we want to do it. Availability zone placement, I don't have a preference. We can specify which ones if you do have a preference. Quick side note here, fun fact. When you see availability zone inside your AWS account, that little letter at the end, so A, B, C, D, E, F, I think we've only got, the biggest one's got 6 availability zones.
Yeah.
Your availability zone A might not be my availability zone A.
They can be actually different data centers. Yeah.
Oh, yeah. So always use the availability zone identifier. There's a different value that you can use, and you'll see that what that mapping is when you dig into this. And this is important if you run across multiple accounts and you have different services calling across the accounts, and you expect zone A to be within, AZA to be the same AZA as the other one's one. Cool. So over here, we can see this is now what it looks like, and I need a security group because this is a physical server running. So I need to define what and who's allowed to actually access it. And then also encryption. I can decide to say, listen, encrypt all the data at rest, and I can use the default key or a customer managed key once again. And I can also do encryption in transit. So between the different Redis nodes and when I connect from my client to the Redis cluster as well. You can see over here, then I have to define the access control policy for that. So I'm just going to not select that for now. And then what you can do, and this is also useful, is to actually seed the database with some specific data. Now, this becomes super useful, for example, if you've got a lot of session data that you've already stored or some data that you want to access very, very quickly. Because an empty cache, guess what? You're not going to be able to hit any of the items in cache. Excuse me. Sorry. We don't have any seed data, and over here you can see we are very friendly. We've got the enable automatic backups already set up, and you can change this retention period between 1 and probably 31, if I have to guess. Yep, 35.
I will have to jump off. I have some construction folks coming into my apartment right now, so thank you for having me. Thank you for having me, and good luck with the rest of the thing. And thank you all for joining the stream.
Okay, I will put the photo of you on the wall and pretend that I'm still talking to you. Cool.
Please do. Bye.
Thanks for joining. Cool. Okay. Now I'm on my lonesome self again, so hopefully the people in the chat will keep me company and ask me questions. But we are busy setting up this cluster. Let's go over here. And now the next space is that a maintenance window is that when you want to apply, for example, a minor patch upgrade, you can do that, or if you want to change values on this database. That normally can be postponed till the next maintenance window. So if I go ahead and say specify the maintenance window, I can say do that on, let's say, Saturday at 3 a.m. because we know that nobody's using the app at 3 a.m. at that point in time, and that's the least likely for something to break. And also I can specify the duration for things or for that windows, because sometimes it's randomized inside that window when a specific operation kicks off. Because as you can imagine, let's say everybody goes ahead and sets their maintenance window for 3 a.m. on Saturday. We don't want to have all of the clusters in an entire region do updates at the same time. So there's a bit of randomness in terms of when we schedule it inside the window. Then what we can also do is we can set up notifications via SNS, which is simple notification service to let us know about it. And then ultimately we go ahead and we just say, boom, create. And now this will take a few minutes to obviously create our cluster. Luckily, what I've done over here is I have set up a clustered one over here already. And we can see that if I go into it, this is one that I set up slightly differently. It spans 3 availability zones, which means that it's got 3 copies of the data, and we've got 3 shards. So we've got them sorted, and you can see all of the details over here. So if I click, for example, you can see the slots, key spaces, how it allocates it evenly between those 3. And I can click on one of them if I want to go look at the shard itself, and I can, for example, see all the individual instances in here. And I can also see that they are in sync at the moment in terms of the parameter groups and the fact that the individual nodes are available. Now I can, for example, select a node and say delete node, which obviously we don't want to do, but we can also simulate the failover. So when you are building systems with a clustered cache like Redis, or rather, if you use the clustered mode in Redis, which you should, always come test this. So at some point, run some kind of scenario where we say today we're going to be testing our failover, and be prepared to see what the behavior is and make sure that your app behaves the way you expect it to. So do that, let's say, on a dev environment or a staging environment, or if you want to in production when it's quiet, so that you know that it actually behaves the way you expect. Quickly, are there any questions so far about Redis in terms of what we've done so far in terms of setting up this cluster? Just going to give it a second. Nope, no questions so far. Cool. So now what you can also see is if you look down here, you can see that you can see some values over here. You can see the CPU utilization. Now, once again, remember the cluster that I created was using the T family, and the T family is a instance class that uses credits, and you can run out of CPU credits, in which case you'll be limited to your baseline performance, which is a little bit sorry, there's a question here. Sharding, so it's sharding with a S, sharding. So what sharding is a mechanism to get more performance out of databases. So what you do is, let's say I've got a data set. Let's use surnames. what I can do then is I say, I'm going to shard this into 3 shards. So I take it and I literally break it off into shard 1, 2, and 3. And then I have what's called a shard key, which is the way that I decide if I give you a surname like mine, Bernard, in which of the shards is this going to go. Now, a very basic sharding strategy would be to say everything between that starts with an A up until including an F goes into shard 1, and then G to M goes into shard 2, and then N to Z goes into shard 3. Then along comes a new user or a new piece of data. The key is Bernard with a B. It says, it starts with a B. B means it goes into shard 1. So it's just to get better performance out of your system and actually spread it out. Now, all of this sounds great. There are some trade-offs, however, because remember, if your individual instances then start filling up and you get to a point where you can no longer scale them vertically in terms of add more disk space, or they can't perform their queries quickly enough on them, you have to do what's known as resharding. And what you do then is you say, okay, cool, I currently have 3 shards. Now I need 4 shards or 5 shards. What happens then is that you change your sharding key and say, instead of being split into 3, and I split it into 5, which means that I know when new data comes in, which of these 5 I now need to send the data to, but you have to rebalance your shards. Because remember, initially your shard 1 had A to F. Now version 2 might only need A to D. So keep the data over there, but it needs to get rid of data E to F. But before it can get rid of the data, it needs to take data E to F and put that on shard 2. And shard 2 needs a portion of what shard 2 used to be and send data off. So it's got this rebalancing. So that's going to be a period of heavy activity. So just be careful when you do the sharding strategy. Read up and think about how you want to split your data and all that. But with regards to caching, this is a mechanism to get a lot more performance out of your cache as well. Let's just quickly have a look. On pagination and partitioning tables. So just quickly, partitioning tables is a similar concept. The difference is that with sharding, so with partition is that I take a table and I say, take the data and create partitions in the data, where a certain set of data that I know how to get to that using something similar to a sharding key, but the actual data is still on the same instance. So think of it like partitioning, but I take the data and I spread it across multiple different nodes, is one way to think about sharding. Let's quickly. Okay, yeah, that covers the questions. Any more questions? I actually enjoy the discussions more than just presenting and randomly continue with things. So please send me more questions. So look. Okay, all good. Cool. So what we have here on the left is you can actually see some statistics about your instance as well. There's quite a lot of rich data over here, as you can see, and you can always query this and actually build this into your CloudWatch dashboards as well, and do some interesting things based on this, set up some CloudWatch alarms, etc. Quickly, what about, let me pop it up here, to manage cluster. What about migrating from a Redis cluster that you've got hosted into an existing one? So what I would do for that, and it'll be a multi-step approach, is that you should be able to export the data from the existing one and import it into the current running one, either by saving the data into an S3 bucket, and then when you spin up the cluster, have that as a seed data to actually start off with. Or what I would actually do is I would change my application to, when it writes data to the cache, let's say I've got the cache over here, the old one, I'm using it, I'm reading, writing to that data the whole time, is change the way my app works so that it actually does a double write. So it writes to both sets, but it only reads from the one side, the current one that you're using on-prem. And then what you'll do is over time, you'll get parity in terms of the data in terms of the 2 different caches. And then I'd flip the application with a feature flag and say, cool, now start reading from this new cache and confirm that everything is working the way you would expect it to. If it doesn't, you disable the feature flag, you go back to the old one and you figure out what's wrong. Because otherwise what's going to happen is you have that problem with an empty cache or a cold cache where it actually degrades the performance of your app too much. So you want to be able to pre-populate the cache as well. And populating cache on the fly is something that takes a bit of time. It's a little bit more. There are many ways you can do it. Like I say, you can do a bulk import, and then as soon as the bulk import is done, and while it's going, keep on writing to it as well. Or if you can take your system offline and copy the data across, it depends quite a lot. But I mean, remember, this is also, it's the same in terms of the interface Redis as you would with the open source tool version. So any tool that you can use with that, you can connect to the through the port and actually run those types of queries with it as well. Cool. Let me just check over here. Any more questions? I think what I'm going to do is I'll take questions for the next 5 minutes. Because basically all I wanted to show you today was a little bit of DynamoDB and a little bit of Redis, given that this is literally a getting started, and just to show you and point you in the right direction of some info. Yeah, okay, Denny $1 is mentioned that there's something open sourced for Memcache that you can do with this. Well, let's quickly take a look over here. Redis migrates data. Let's see what we come up with. DigitalOcean. Let's see what the tutorial is. How to do it. So you SSH in, you authenticate, you add some data, then you expire it, backing up your source Redis instance. Okay, so Redis does have actually a BG save built into it that allows you to export the dataset and import the dump file into another Redis cluster. So what you can do is you can probably set up an EC2 instance and have that set up the appropriate firewall rules and be able to get the data out of the existing Redis cluster. So immediately do the BG save and immediately push it back into the new cache and then change your app configuration. Like I said, it's one of those, because it's cache, it's ephemeral data, so you would expect to be able to redo the data. So let's take user sessions. If I'm taking a large volume of data and I grab it and I immediately just send it in to the new cache and then flip over and point to it, I might lose some entries in the cache, which means that a user might get logged out and they might have to log in again. Now, depending on your type of system and application, this might be acceptable. Remember, always take a step back and say, listen, do I need to do things in complete real time and also without any side effect? Because sometimes, because that's very hard to do. But if you can take certain things into consideration, for example, being logged out and having to log in again, yes, it's annoying, but let's say that happens to 0.1% of your users or 2% of your users, that might be acceptable. If it is acceptable to you, then rather go with a simpler solution with that side effect than trying to go with a complex solution where people don't have to log in again. It's just, that's my personal recommendation based off that. I've seen too many people try to be fancy and then break it where it breaks for 100% of the users instead of just those 2% that would have been inconvenienced and not broken, inconvenienced. Log in again is not the system being broken. It just means that, oh, your session got lost. You've all probably experienced this at some point. You logged into a system and for some reason it asks you, hey, okay, just log in again for whatever reason. Cool. Some more questions. Where's my mouse? Okay. There we go. There's my mouse. On DynamoDB, how would you approach if you have to implement pagination on millions of rows of data? My guess is using scan would be the best choice, right? So this is a very long discussion. The reason is that pagination is one of those very, very difficult things to do. The reason being is that your data keeps changing under your feet unless you've got a database that's in read-only mode, in which case it's much easier. The reason it's hard is that, let's say, I want to create pagination that tells you that here are the first 20 records of all users in the database. When you click next, you get the next 20, next 20. It seems simple what you want to do, but under the hood, new entries can be inserted. So let's say I'm sorting by surname, and all of a sudden page 1 had A to C, and I show you that on the screen, and here comes Quibus, he registers, and because his surname is Bernard, he gets inserted into the gap. Now, at the bottom, there was someone with, let's say, a surname with, use a local one, Kutsia. And that was entry number 20. You had it on page 1. Now you click go to page 2. And because you keep track of the data, and you said, well, page to page 2, and so give me records 21 till 40 to display. Now all of a sudden, record 21 is that Kutsia one, which you just saw on the previous page. You're like, but what's going on here? I saw something else. What's going on? So what you can cache it in memory somewhere for a certain period of time and say, listen, let me get that in one go. And then as you paginate, we say, get the next one, get the next one, get the next one. The risk, however, is that the data changed underneath and now you're sending stale data. So it's always a trade-off on how you want to approach pagination. But adding pagination to large data sets is definitely a good idea because you don't want to overwhelm the network by sending too much data over the wire. Because imagine doing get me a million rows without pagination. That's going to kind of take a while to get across the wire. Yeah, so Denny, double and as he's saying is like it depends. It's one of those like there are a million ways to do it, but it's actually one of those in principle, it sounds simple, but it's actually quite hard to figure out the nuances and exactly what's the expected behavior. What do you do? Because as a user, I would expect the data to literally just show me the next page, and I'm not thinking about inserts, deletes, cache data, all of those things. So it's actually quite a fascinating topic to look at. Also good point. There is a 4K limit in the DynamoDB response in terms of the size as well. Next question. Skip operator, for example, in this pagination, the last row always appears first on the next page. I'm assuming what you're asking is to skip certain rows if they were on the previous page, or if we showed them in the previous page. Ridix World, if you can just clarify that for me. I'm trying to understand. I mean, you can set up your pagination to always have whatever the last row was showed as the start in the next one. But like I said, that might get confusing if it actually did move by one, because now it's no longer, technically it's no longer the last row of the previous page, because it's no longer that previous page. So it gets complicated again. Like I said, it's a quite an interesting situation to be in. Cool. Let me know about the rest of the questions. Let me just scan quickly, just to make sure that I didn't miss any. Yeah. Okay. It seems we've got all the questions so far. It is 1:15, so I am going to say thank you very much for joining us. This will also be the last session for this year. We will be continuing with Developers Let's Code next year. The main reason for this is that we are heading into what's known as the pre-invent season, and soon we will be in reInvent. reInvent is our annual conference that we usually host in Vegas or Las Vegas, Nevada. But given that we've got this massive worldwide play going on at the moment, we are not doing an in-person event, which is great news for everybody, because it means we are doing a virtual event, and also that virtual event is free, because normally reInvent is a paid event. So if you go to reInvent 2020, let me just quickly bring up the page. You can start getting some details over there, and also see what sessions we're going to have and some other details about the event as well. I would highly recommend this if you want to learn more about AWS. It's all the way from new features being released, new services being released. Watch the keynote. The keynote is always a good idea, because it gives you an insight into where the industry is actually moving. What are the trends that we see? What are we focusing on, and why we are focusing on that? So highly recommend. Like I said, this year it's free. Normally, I think a ticket last year was like $1,800. So it's a great opportunity to actually be part of this event and not have to travel as well. Let me quickly just double check over here. There's a question about specific use cases where you choose Redis over Memcache. Dennis actually answering it, like always, it depends. I mean, if there's certain features that you want from the one that the other one doesn't have, I personally don't have enough experience with it. I'm used to some systems by default had Redis as the default caching mechanism. Others had Memcache. Yeah, it's entirely up to you. But with that, I'm going to say thank you very much. And it was great to actually see some of our regulars again. We'll hopefully see you in some of the other streams. Today is Wednesday already, so there is another stream tomorrow at 12 o'clock my time, which is South African time, which is 3.5 hours in the past. So if you want to come back to the stream tomorrow, that's a general question session where myself and Darko and some other people will be available to answer questions. So please come join us there. And yeah, with that, I'm going to shut down the stream now. Thanks for joining. Bye.